I'll just take now 5 minutes to give you a little bit the scope of what we are aiming for this workshop today. So essentially, as introduction, when we first discussed active space debris removal as a topic that we might want to look closer, it was at a seminar in 2009 that we organized together with CNES in close to France, where space debris and active space debris removal were jointly identified as being one of the elements one of the topics where we want to go a little bit deeper. Now, space has long been considered, like all new domains that humanity discovers, as an unlimited resource, looked at infinitively big, and the perception of space was it's so large, whatever we do, we cannot make any impact on it. It's very similar to when we first discovered the Americas. We just explored it, they used it, and we didn't care about actually what we did there, because it was so vast that human activities couldn't make much of an effect. But then in the 70s, the first serious work on orbital debris started. Probably the first real landmark paper was by Kessler in the late 70s, based on a model that he used a few years before on asteroid belt evolution. And it's interesting to see that this asteroid belt evolution paper that he published back then was published just a few weeks before the Voyager spacecrafts were launched, and it was not at all clear if Voyagers could traverse this asteroid belt undamaged at the time. There were a lot of speculations of how dense this belt might be and how high the risk is. And Kessler essentially showed that the risk is less important than many fear. And he then used this model also for space debris. The first mitigation measures for space debris that I am aware of started in the 80s with upper stage venting, and gradually matured into what I think is now the core document describing best practices with respect to space debris mitigation, which are the debris mitigation guidelines by the IDC, published in 2007 in the framework COPOS. If there are any questions on this, Monsieur Bonal is probably one of the leading experts in this committee. But we are not going to address mitigation at all in this, because there is a gradual acceptance that even if we don't do anything, and even if we implement mitigation measures as foreseen, we might have the need for actual debris removal in order to avoid some runaway effects, which are usually called the Kessler syndrome, or Kessler syndrome. Okay, now the situation for us was that when we first looked at it, there are many concepts, mainly theoretical concepts out there, published in various journals and conferences. There was relatively little serious attention given to it on active space debris removal concepts and technologies until not so long ago. And we had the perception that this was a topic that was well suited for academic ingenuity, for new research ideas, for innovation coming from maybe not only to traditional space actors. So we formulated what we call an Ariadne call for ideas, where we specify a generic problem area, and we ask for ideas addressing these, research ideas, because this is what the Advanced Concept Team is all about. It's about research. So the main purpose of the call that we started in 2010 was to perform research on new and innovative scientific and technical concepts and techniques for active space debris removal. So you see it's relatively large. We didn't want to constrain it. We didn't constrain it to an orbit. We didn't constrain it to a type of debris. And we didn't constrain it to a type of methodology of removal in this classification tree. So we really were looking for a broad range, and we got a lot of interesting proposals, of which we selected 3. But just to give you the frame, so the call was opened in May 2010, closed on 18th of June 2010. We had the evaluation board 10 days later, and negotiation and kickoff meetings in the weeks that followed during the summer 2010. The actual work then started end of the summer, so in end of August, beginning of September, with the actual kickoff meetings. Within ESA, and that's important to mention, this was a call that was not entirely done just by the Advanced Concepts team, but we were closely cooperating with the ESA Space Debris Office in ESA Darmstadt. So Heiner Klinkrad was central to the definition of what we were proposing in the first instance, and also who we selected as partner universities in the second instance. Then this is an activity that is performed within the General Studies program, where there are several other activities related to space debris and also space debris removal. And I want to highlight here specifically the contribution of Joris. Joris Olympio was a research fellow who led the definition of the call, and he's now in Toulouse, so he left us in the meantime. He was still very much involved during the call in the review of the studies, but he couldn't join us today. So the 3 studies that we have conducted together with the University of Surrey, Polytechnic Madrid, and the University of Pisa are what I would consider 3 shots to this problem that are very different. I think also due to this quite complementary, but far from being a real exploration of the whole research domain of active space debris removal. So the first one, which is not the first as such, but just the first I mentioned, is maybe also the one with the highest TRL level from the conceptual point of view, is one by Surrey on hybrid solar sail for active space debris removal. The second one by University of Madrid on an ion beam shepherd concept for contactless space debris removal, where an innovative way of using propulsion will be presented. And the last one is the most passive of the three concepts, where an expanding foam is used to increase the drag of debris, performed by the University of Pisa. Now, unfortunately, we have some changes in the speakers for the agenda, because Vajos Lapas from Surrey is fairly ill, so he sent me an email yesterday that he cannot come. And Mr. Ruggiero also had an urgent other appointment. He just got notified yesterday. So the names are no longer correct. The way we do, since 2 years now, the final presentation of Ariadna studies is that we make, in the beginning, 10-minute, what we call executive presentations, which are there to give all the main elements of the study in a way that people who might not have time to come here today, or people who might want to look at it offline during a coffee break, like TED Talks or YouTube videos, can have a quick grasp of what we did, and if they're interested, then they read the paper, the reports, and maybe look at the full video. So these three executive presentations, we scheduled them in the beginning, and then we go for 1 hour for each of the presentations right afterwards. So this is essentially what we have for the Ariadne part, but since we are addressing only small research aspects of active space debris removal, it was interesting to have here in this frame presentations that give us a little bit the larger frame. And there will be in the afternoon, as a second part of this workshop, one by Holger from ESA, from the Space Debris Office, one by Ian or Andres, because I don't see Ian yet, in Paris.
It's okay.
Only here, yes.
Andres is there and Ian is coming and going, but he's around.
Unfortunately, I will not be here yet.
Okay, we'll be that's fine.
So I understood also from yesterday evening that Ian probably would go first because he gives more the general frame than Holger, and then a presentation by Christoph, who will present what CNES has done recently, but also on a purely technical aspect. So actually the room setup here is one that is suitable for an interactive technical workshop. So we are sitting around 3 tables. Feel free to move around also if you want, and also feel free to interrupt the speakers at any moment, except for the executive presentations, because these are the ones that we want to put online, disseminate widely. So it's good that they are a little bit coherent within these 10 minutes, and there's not too much interruption within them. Are there any general questions that we should address before starting with this executive presentation?